students, if you're new to this verifying identity or establishing identities or proving identities, you may feel a little puzzled. So that is normal. Let's work through this. It's like a game, okay? And there are a couple rules of the game. Here are 5 major rules of the game. And I use the word game because I'd like you to consider it as a challenge, like it is a game. See if you could figure out what you need to do. Let me go through these rules, and please look in some of my example videos of how I apply the rules. All right, let's look at rule number 1. Work with each side of the equation independently of the other. Start with the more complicated side and transform it in a step-by-step fashion until it looks exactly like the other side. So if we notice in this example, the left side looks more complicated than the right side. Now, rather than working down, I'm going to just remind us 1 over cosecant is 1 over 1 over sine. And secant is 1 over cosine. Well, 1 over 1 over sine is just sine. And then we have cosine at the bottom. Of course, I should put my x's here, okay? And that transforms itself into tangent. So I did end up with what I was trying to do. I was trying to find tangent. That will be rule number 1 example. Okay, here's some other advice. Analyze the identity and look for opportunities to apply the fundamental identities. This is why it's important to have your sheet with you. And then try using 1 or more of these techniques. Okay, so that's the gist of it. Rule number 1 I showed you. Rewrite the more complicated side in terms of sines and cosines. Number 2, factor out the greatest common factor. So let's see what would be an example applying rule number 2. How about sine x, cosine x, plus cosine x over sine x plus 1. And we're to prove that that is equal to cosine x. Well, notice on the top we could factor out a cosine x. If I factored out a cosine x, that's going to be sine x plus 1, sine of x plus 1. And notice the bottom is sine of x plus 1. And notice these would divide out, right? So I'm just left with cosine x. I'm just left with cosine x, which is what I was looking for. So that'd be an example of number 2. Okay, look at rule number 3. Separating a fraction. This is really an important idea. Notice on the left side here, we have a common denominator of sine x. So I'm going to rewrite that as sine x over sine x. I know it sounds like sinus medicine. Plus cosine x over sine x. Well, let's just think about this for a moment. The sine x is going to be just 1 plus cosine over sine is cotangent. Okay, and lo and behold, that's what I was looking for. That's a good example of breaking them down or splitting down a fraction. Okay, folks, this is the other part of 3. Now, notice on the left side that I have, actually, that's not. Okay, now notice over here on the left side, I've got a common denominator, and I could split it up into 2. Sine x cosine x over cosine x, and then plus cosine x over cosine x. Well, we know this part's just going to be sine of x plus, and then this part's going to be 1, which is what I was looking for. So that is a helpful step, and that is taking a expression and breaking it up with the denominator as a common denominator. All right, let's read number 4. Combine fractional expressions using the least common denominator. This is a good question right here. Let's see. Now here we're adding 2 rational expressions using trig ratios. the common denominator is going to be cosine x sine x. Okay. Now remember how I did this. You're going to have to multiply the top by sine x, that's sine squared x. And then you're going to have to multiply this by cosine x. Now that didn't give me a big revelation there, but that is a step that you need to be able to do in working with trig identities. All right, now look, number 5, multiply the numerator and the denominator by a binomial factor that appears on the other side of the identity. I don't have something over here at the right side, but I got a piece of advice. What I would do is multiply the 1 minus cosine x by 1 plus cosine x. And when I do that, of course, the top is just this sine x plus sine x cosine x. Or better yet, hold on here, let's see. If I erased this, sine x times 1 plus cosine x. Now remember, the bottom's going to be 1 minus cosine squared x. But wait a minute, we know that sine squared plus cosine squared is equal to 1. So 1 minus cosine x is just sine squared x. And in this situation, although I'm running out of room, one of the signs would divide out. So my final answer is just going to be 1 plus cosine x over sine x. Now, and that may be helpful, maybe not helpful. Okay, let's look at the last bit of advice. Don't be afraid to stop and start all over again if you're not getting anywhere. So creative puzzle solvers know that sometimes your idea didn't work out, and don't be afraid to try again and again. This is why it's important to look at it like it's a game. After a while, when you get a lot of experience under your belt and you've become familiar with the identities, that will help you out. So verifying identities may not be as fun as some of the games that you played in your life, but it's an academic game, and actually some people do like it. It's a good academic challenge. My advice is have that trig sheet near to you where you could kind of just remember all of the identities and just take the problem one at a time, and those that you get stumped on, sleep on it. You need some help, reach out for help. It is available. I hope this little video gives you some insight into the rules of verifying trig identities. Best wishes.